So once we create this model, we actually superimpose the loads that the engineer record will give us so that we can structurally design and engineer the floor trusses, roof trusses, and wall panels, and make sure that we're taking care of vertical load distribution, and the structural integrity of this building will be perfect, hopefully, by the time we get done with it. Also, in some situations, we can give viewers to the customers. So if they wanted to add vaults or tray ceilings or things of that nature, we can do that. Once we get the model done, we actually take each individual truss and we analyze it. We will take the roof truss and superimpose the loads. At that point in time, to keep this truss in equilibrium, it will design the connector plates to the appropriate size. It will also tell us the materials that we need to use within the truss. We use what's called MSR material, which is machine stress rated, and we have values of 1800 to 2400, which means it's the compression rate of the material. So we are totally engineering each individual component, determining the size of the connector plate, and making sure the structural integrity of this building is adequate. Here's a representation of a wall panel, making sure that when you see the browns, it's sharing with us that we got a key component. And once we get all this information done, we hand it over to manufacturing, and Tori Taylor is going to take over and share with you how we go to manufacture panels, roof trusses, and floor trusses. Go ahead, Tori.
Fantastic. Good afternoon, everyone. So we've got some video clips of some of the manufacturing processes that we have going through the component plant. And we're going to show some videos here if it works here. Let's see here. That's cool.
It works the 15 times we tested, but the one time we need it to work.
1 second here. And while we're getting this video up, is there any questions so far in terms of the design process that we've just explained?
Well, why don't I share one point that we have designers all across the country. We have designers in New York, Oklahoma, Nebraska, Phoenix, Arizona. We have several at each location, and we work independently and have set up a remote type application to do design. So we are actually catering or actually getting some of the best designers across the country, and not limited just to the people in Colorado.
Wonderful. Let me try something else here. There we go. All right.
All right, fantastic.
Hopefully everyone can see that.
Trust me, you didn't want me ad-libbing for 45 minutes. So ultimately what's going on here in the panel process, it just zoomed in on the screen there. All of the design software is integrated with our system. So each cut, each angle, things of that nature is automatically loaded into our software in the production shop. So what this person is doing here is they're loading material for the bottom and top plate to do layout of the wall. So he's going to be cutting here the material, and that the length is automatically set up. And then the pusher moves back, and he's going to mark every location of where the studs belong, the openings belong, like window openings, door openings, things of that nature. So that's what he's doing here. So it's very, very precise. It takes a lot of the human error out of it, where, you know, if you're using a tape measure, you can put a wrong mark there. It's nice to have a system to make sure that we instill quality right in our process. So that's what this gentleman is doing here. He's just marking the layout where the locations go. So we'll continue through this video. Again, there's software integration. This is where we build the openings. So the door openings, window openings, things of that nature are being built right here. And we can just kind of watch him do some assembly.
And we've created a paperless environment so that we don't have to shuffle paperwork from job, from station to station within the plant.
Yeah, before we were paperless, you know, transitioning between day shift and night shift to day shift. You know, if there's a chance a paper can be lost, it will be. So it's been nice to have it all integrated. This is him working at full speed. We've kind of sped it up a little bit to kind of see how a wall opening progresses. So here we go as he builds that. Okay, so once the wall opening is built, it's very simple. It's just an assembly line. So they're going to push it down to the next step where they push into the opening into this station. So the parts and pieces that were cut in the first video that we watched, they cut it in sequential order. And so now what they're doing is they're putting the layout pieces on the top and bottom. They've moved the opening that was created and they're fastening it in. So they're just nailing it in. Next thing that they'll do after they've got the opening secured is what they're doing now. The gentleman on the far side of the video, what they're doing is they're throwing in the studs. Depending on, you know, the design files will tell us what the stud heights are, and all of the cuts and stud heights and everything are pre-configured. So now they're just throwing in the studs there. It's a nice tight net fit, as you can see there. And they'll get the product here in the wall. Okay, so the next step, we'll go to the next video here. It moves down the line. This is where we square the walls off, make sure that they're nice and square before we apply the sheeting. You can see that row of nail guns on the very back. That shoots upwards of 20 nails at a time. And we use, for the vast majority of the walls that we build, we use that bridge, which has a lot of time savings and some efficiencies there. This particular wall that they're building is for a hotel, which has a lot of shear application where it required a beefier nail. And so as they nail this off, they're going to be nailing it off manually. But what's nice is all of the nailing specifications and things like that, again, is integrated with our process right into our software. So it tells them how it needs to be nailed, the on-center spacing and things of that nature. So it's really down, it's literally at the detail of every nail is specified out, and we build it to those specifications. We'll watch a kind of a fast forward review of them nailing it off. So they go through, they're chalk lining, so it's nice and straight. That's what they're doing there. All right, so before we move on to trusses, are there any questions or comments about wall panels?
David Baltz had a question here. What steps can a builder take during the design and panel review process to ensure panels fit, openings, bearing points are in the correct place, etc.? So one thing we do during the design process, we have a submittal process where we'll go through and design as best we can with the plans that we have, the information we have, and we'll submit that off to the customer, the architect, the engineer, potentially the framer as well. They have the opportunity at that point in time to go through, our designers will go through and they'll cloud areas that they may have had questions on. They may even put some questions on the submittal itself, and we'll try to go through that process of having them back and forth. More complex jobs or bigger jobs, we will actually do pre-construction meetings, or we'll try to get the designer, the salesman, the customer, whoever that may be, and potentially even Tori involved, where we'll go through and try to get as much of that stuff worked out ahead of time. It's a lot easier to change designs on a computer screen than it is when the wood's already in the air.
Yeah, and Craig, you make some really good points. One thing that I would add to that is The more time that you take up front and the detail you give up front, probably the smoother it's going to be in the field. If you give us plumbing drops, so we know where your plumbing drops are, we can potentially space some of our components one way or the other, so there's not a conflict there. Also, if we know where the mechanical is going and things like that, we can compensate for those types of things right in the design process. And it's been our experience that those who do take the time on the front end really reap huge benefits on the back end.
Right.
Okay, so are there any additional questions before we move on to roof trusses and floor trusses? All right, let's move forward. All right, so now we're gonna kind of show our roof truss process first. This gentleman here is picking, and yes, we do pick lumber in the snow and all types of weather. We keep moving, just like our framers on the site. And so we get information brought to the picker. They're picking in reverse sequential order, and then they put it on this live deck, which is just a small system that introduces the wood to the saw. That's what he's doing there. So he'll pick orders and batches and things like that, and they'll put it on the saw. Oops. There we go. So this is a picture of the screen. This machine has 5 saw blades, and one of the ends actually moves in and out for the length. So every piece of wood has a certain length and angles, and it's going through this saw. And this saw can cut about 30 pieces per minute. It's our high volume saw. We do have other component saw that are better at optimizing for pieces that are onesie twosie. And just the other video is, on the outfeed side of the saw, where what this gentleman is doing is just stacking it up in a way that is meaningful to the truss builders. Okay, so this is our jig system. It's a jig system where the pucks automatically set the profile of the truss. Our design software makes a determination of where those profiles need to be. And at this point, all it is kind of putting the puzzle together. So if you see the little pucks along the bottom and around the profiles, that holds the position. And these webs are all cut and the cords are all cut in a way to where it's a nice snug fit. The gentleman on the top of the table, he's just stapling the webs kind of where they go. And you'll see that they use their hammers to adjust it to get it, make sure the top cords and the bottom cords are all planing out nice. So you have nice ceiling lines and nice roof lines. And that's what he's doing there. So they're putting the puzzle piece together there. Next thing they're going to do is we have metal connector plates with really sharp teeth. They're going to nail those connector plates in, or just tack them in rather. And then we'll have a press that's coming through in here a few minutes. So we'll kind of watch this video as they progress here.
And we also have laser projection systems that can show the exact locations of where the cords and the webs meet, the connector plate size. And again, this is to ensure accuracy and take thinking out of the worker's mind and build it into build the software to integrate so that we can make their jobs simpler. Notice they haven't had to take out a tape measure. In some situations they will if things don't fit, but everything is integrated together so that we're pulling the right materials. We have the right materials in the top cord, in the bottom cord, in the webs. And then you can see all the different size connector plates that they're adding there. That is all based off the engineering and design, and that will determine what the size of the connector plate is. Go ahead.
So what this machine is doing, it's embedding the connector plates into the wood so it holds all the joints. It partially embeds it. It's enough to get it off the table, but not quite enough to be up to specifications. And so it holds all of the truss together, and they're going to finish and get to the other side. Then we have automatic pneumatic lift outs that are going to lift this truss off the table and put it on some rollers to move it outside of the building. So we're just going to follow this truss all the way out. That's where it ends there. So it goes on the rollers, and then it goes through a final press where it's the trusses or the connector plates are embedded completely in, and it's a finished product there. So that's kind of our roof truss. Here's floors are similar in that they run through a saw first. And then after that, we assemble it. So this saw cuts open web, the webs for the open web floors. It cuts a lot of pieces per minute, and our stackers are really good. So she's taken these pieces off, and we might have 12 to 1,500 pieces in one floor or more, and we have to run them at a pretty quick rate. So we can load 2 to 3, even 4 or 5 at a time. It's got a little magazine that the saw operator there is loading the saw there. So we'll just kind of watch this for a few minutes, or a few seconds rather. Okay. Next video, very similar to the roof trusses, we're going to be assembling the floor systems. So the only thing in the application is very similar in the way that we build them. However, floors, open webs are built upright instead of laying flat. And this machine, what it does is they'll build one side and then it flips the floor to the other side. One goes out the building and then it flips the floor to the other side and they start the next one. So they back plate it. So the connector plates are the same on both sides. So here they are assembling. Cool things about open web floors, it allows for mechanical and other things to be built directly into the system, beam pockets and things of that nature. So when your ceilings in basements and the ceilings where there's open webs they're nice and clean. You don't have mechanical diving down and that you have to frame around and things like that. It's also easier for subs and people to get their electrical or plumbing through because there's nice wide open spaces to get that kind of stuff through. So
yeah, and we can clear span great distance up to 30 to 36 feet, depending upon the loads that it's designed for.
Yeah, so the spanning ability is superior to a lot of other methods for putting in floors there. So we'll watch the floor goes out and then they flip the floors to the other section and then they start the new floors, they put their webs in. Okay, so before we move on to delivery, is there any questions so far?
No questions?
No questions on chat at the moment anyway.
Go ahead, Troy.
All right. So delivery, we just once we build them according to a certain order to where we can get them on the truck. This is a massive multifamily job, and we call them books or bundles, but ultimately what we're doing here is we load them on a truck. They're banded together. When we get to the site, this trailer will raise up, and it's got a braking mechanism so we can slowly just get down to the tails down to the ground. And once the tails are down to the ground, we back out from underneath it and it lays it down very much like you see it right there on the truck, but it'll be on the ground. And another thing in terms of delivery is our panels are sequenced in a certain order. So it's a little bit friendlier for the framer on site. If they give us, again, when we talked about giving us detail up front, on the front end, if they tell us kind of, we're going to start in a certain corner, or we're going to build in a certain way, we can marry up to some degree the sequencing of those bundles. So we even give a layout that shows where the optimal place on the site is to put all the bundles. So it's in close proximity to where they're actually going to be putting them up. And so again, that partnership on the front end, really understanding what our customers' needs are, really reaps huge dividends on the back end. So that's kind of a little bit about my world. Now we do have some availability in floor cassettes in our Nebraska market, and Casey's going to speak more to that than I can.
So to bring value to contractors, and because labor is such, it's so tough to get labor. What we're doing is we're incorporating value-added services into what we present to our customer. One of them is a floor cassette. And what we do is we actually put the sheething on the floor decking, 3/4 inch T&G, right on the floor trusses. Does that work, Craig?
Yeah, hang on. I was responding to a quick little message here.
Okay.
There you go.
And this is an example that we will sheathe that deck and then they will crane that up to the whatever floor is needed, and the sheathing will be installed. On a multifamily project per floor, it has saved them up to 6 to 7 working days worth of work, and just completely minimizing the time it takes to go from first floor to roof, which has substantial savings. And we'll be able to share that information for you. But we are currently doing this in Nebraska and soon to come to Colorado as our customers see the value in that. But again, as they're craning these in, it's already sheathed, and they can literally be following each other by putting the floor or the wall panels on right after they set the floor cassette system. And it is just very successful.
The anchors they use on those.
What's that?
Mention the anchors they use to how slick the anchors work for.
Yes, we have a quick anchor system where once they get that panel set, it's just like a toggle, and it will release the anchor in order to lift. And that's been a very great application and very well received by the framer.
Kind of functions like a rock climbing carabiner where you pull squeeze the trigger on it and it releases, and then you go to your next wall. It's kind of cool.
So the framers we're taking the thinking out of our framers' mind, and we're designing this all in-house. So we have vertical load transfers that are being accommodated, and we make sure that the quality and the engineering is intact. Again, now the framers aren't having to get out saws. They are installing, and they're not having to perform precision acts, which means that the availability of getting more people and framers on the job sites, they're more readily available. Now, what I'm going to show you here is a side-by-side approach. This happened in Milwaukee, Wisconsin. We are part of SBCA, which is Structural Building Components Association. And we had our building conference manufacturing convention. And what we did for Wounded Warriors, we built 2 houses. One they are identical. One with conventional materials, the other one using components. In this video, we'll do a side-by-side comparison showing you the difference between conventional and components. Why don't you start that, Craig? The one on the left is the conventional approach. The one on the right is using components with floor cassettes and wall panels. And you can see the vast difference. What it equates to in the long run is for every one house built on the left-hand side, stick frame, you can build 2.5 houses using components. And the time savings after we get through this video, I'll be able to share with you what that contrasting cost between conventional and components.
Oh, sorry, hit the wrong button.
So what?
Sorry. Go back.
Yeah, take that through. Sorry about that. But again, they did this side-by-side simultaneous. And like I mentioned, it's for every one house conventionally, you can get 2.5 houses on the component level. Not to mention theft and safety. It's very difficult to steal a 12-foot wall panel versus a 2x10. And theft has become a big issue out, especially at the cost per thousand for materials. It has been a big issue out in the field. So you can see where there'd be a big difference. Also, cleanliness of job site. There's a big difference in the savings there. And with the materials that are used in the process of manufacturing. You want to take it to that next slide?
Make sure you hit the right button this time.
All right. In 1995, they did the same thing at the National Home Builders Association in Houston. And you can see the values. That was a 1,900 square foot home where there's 253 hours of savings in labor, 13 cubic yards worth of material difference in waste generated. And the board footage, it saved 5,300 board feet. In 2015, it was a 2,900 square foot home, and there was a savings of 223 labor hours, 14.5 less waste generated, and 5,591 board feet less. So in terms of 2021, those dumpster fees would be about $380. The labor savings is about 11,170 based off of loaded labor of a framer. The material savings of $6,709, especially when we're getting up at the high price material. And the cycle time is $4,900. And what the cycle time reduction is the amount of taxes saving, your interest rates with loans, and the ability to get under roof quicker, and the ability with our production builders to put it to market quicker. So all that totals is $23,159 in savings between using conventional materials and components. This is excluding theft and safety, which is accidents, which is a framer's nightmare, plus their workman's comp rates are the highest. And it's safer because it's a cleaner job site, and they're installing and they're not having to measure and do things of that nature. So their overall labor savings as well could be as they don't need as higher experienced individual as well. And with that, are there any more questions, Craig?
No, there was a question about material savings, and I think we hit on that. If there's any other questions, I think.
If not, Barb will hand it back over to you.
Have you guys looked at, I'm sure you have you looked at taking it one step further to windows, possibly pre-siding, things of that nature?
Yes, we're always dabbling in that. Windows is an interesting. It's interesting you brought that up. We did do windows when I was in Indiana years ago, but the challenge that we have is the handling at the job site. And we noticed that the ones that we installed the windows on, we had more warranty issues because they got jarred or mishandled, or a 2x4 goes through the middle, as they were bracing the panels. So it really it depends, but you can, yes, it can be done. Another issue another savings that we've been taking a look at as well is applying Tyvek. We get into some challenges because the building inspectors can't see the nailing on the exterior wall application. So that's been an issue. We also are exploring the opportunity of spraying foam and insulation in it. And so, yes, we look at, we like to lead the industry in trying to bring whatever brings value to our contractors.
We do have a question about what are the best products to use panels?
Very good question.
What was it?
What are the best types of buildings to use panels?
Oh, we're finding it can be on any building. Obviously, if you're
With
dealing
upfront work, yeah.
yes, with enough upfront work, but what really makes a big difference is we try to stay away from those where you have the 3-story windows and the wind loading where they incorporate steel, but it can be used in any wall panel. But when you get into the chopped up high-end customs, it's one of those to where if that foundation isn't perfect, and if there's different bearing elevations with the foundation, that's where it can get a little crazy. Not that we can't build the wall panels, but we got to make sure they're pouring the foundations and the slabs. But we're where we use them most is in multifamily and in production builders as well.
But we do have some custom builders as well that take the time up front to get it designed properly, and they're verifying their foundations and things of that nature, which allows us to even do wall panels on kind of high-end custom homes as well.
Right.
So
Yeah, the model we showed was a high-end custom home that we did do wall panels on. Got another question. What is the upcharge percentage for doing the design and production? 23,000 in savings is amazing, but to design this fabrication costs 4, 8, 10,000. How much is doing the components
No,
offset on?
that's really a true comparison. Now and that's a great question, because the one thing is that I'm probably not paying the same amount of labor to sheathe wall panels that they are in the field. So I'm not even bringing in those cost savings, because I am not charging what they're charging in the field. So the design fee, that's an interesting one, because it's a tough one to compare, because how much time is a framer going through it, trying to discern what rafter cuts and things of that nature, versus us using some pretty sophisticated software in order to do that. A design cost on a building can range from, all depending on the complexity of the project, from $50 to $1,000. But the savings also is, we have found many times where architecturally what they drew was misrepresented, and we saved them a lot of money in trying to correct errors.
Got another one here. Do you offer pre-framed window door openings or pre-cut packages for windows and doors?
Yeah, well, we have competition that does that right now, and we would do that. They call it ready frame walls, and they pre-package that. We call ours already framed, and we have done that in the past. We've done headers or things of that nature. That's something that we could do. The design expense is the same, because we literally have to do the whole building, and we would just rather take it one more step and frame that for you.
Got another one. When building with panels, you often end up with larger stud packs at panel to panel joints that have a tendency to reduce energy performance and R value at that section of the wall. How do you see that being worked around or improved?
Oh, that's interesting, because we've been, especially in Nebraska, we get those, what they call cold corners. And what we do, we take the extra time to try and look for that, so that there can be insulation behind where those get together.
I think he's asking about where the panels butt together. I know we hold the studs back a little bit, so there's a little bit of an air gap between them that could be insulated with some sort of foam potentially.
Right.
The question is that gap going to be large enough for that? But yeah, it's a
very good comment.
very good question.
Yeah, I think so. So we'll set back one truss and we'll have an overhang on the other. Or not truss, but stud rather.
Right.
We'll hold it back and then have a flap that overlaps to try to take care of that, as well as, so there's definitely options there. The other thing that we do in like where there's where a wall ties into another wall perpendicular, sometimes we allow, or we keep the C channel apart out, so insulation can be added and a stud can be thrown in.
Right.
As well. So there are options to get those types of areas insulated.
Yeah, and we run into that more with the corners and the joints, like these guys have mentioned, and that coming up at the actual where the walls butt together. But yeah, that's something to think about. Good questions.
So I have a quick question. Did you say that this was not available in Colorado at this time?
No, everything. The only thing that we're not doing at this time, because it wasn't requested, would be the 4 cassettes.
In Colorado.
Oh, I see. Okay. And how many builders, how many of your builders are doing this right now?
The good majority of, of all the products or just floor cassettes?
Really, yeah, just of the, well, you could kind of give the breakdown of, how many are using these components, I think would be really helpful to kind of
Gotcha.
hear,
So
what they're doing.
I don't know if anyone's stick framing in this market. So 100% of our customers are typically using our roof trusses. And floor, open web floors, I don't know the percentages there.
Yeah.
Anywhere between 30 to 50% is probably using open web. And then panels is probably another 30 to 50%, kind of in that range there. Yeah, and it really comes down to, as labor tightens, the demand for panels tends to go up. As availability or prices increase on, alternative products, open web floors tends to increase in demand as well. But yeah, most products of our customer base, it's, 100% is using components and 50% is using probably wall panels, something like that.
Okay, great, interesting. Okay, are there any other questions? I mean, this has been really informative and I think it's been great. And then we've got something here that says reduction in
I
size.
got another one, just another quick one here. Do you have a reduction in crew size with panels and components?
Yes, generally a standard, and it's different depending upon where you go, but generally in a conventional frame situation, the amount of laborers on the job site is anywhere from 4 to 9, or actually 5 to 9. If you have a 9-man crew, you could probably break it down to 2 4-man crews and be working on 2 houses at the same time.
And I've seen single family or production build work where they had a 5-man crew and they literally just had one person on the lift lifting the panels on, and they had a 2-man crew setting them. And so, 3-man crew total. So
2 people supervising?
yeah, that's right. Or on another house, right? Yeah, we've seen people, go from, week and a half to 2 to 3 days in getting it up to where the components are on.
Okay, great. Thanks again for everything. Any other questions before we close for today? Okay, well, thank you all very much for joining us today, and look for more information to come in the future for our programs and the app that will be coming your way. So thanks again. Have a good day.
Thank you.
Thanks, everyone. Have a good afternoon.